What if I told you that the water in this glass is ancient? That the very stuff it's made of, the hydrogen and oxygen, has been on an unbelievable journey, stretching back across eons. Some of the hydrogen is primordial, formed in the Big Bang itself. The oxygen was forged in the heart of a long-dead star. They came together and have been part of a cloud, a raging ocean, a drink for a dinosaur, and even ice on a comet. This sounds like science fiction, but it's not. The molecules in this glass have witnessed the birth of our planet, the rise of mountains, and the entire history of life. This isn't just a glass of water, it's a liquid time capsule. And we're about to open it. Cosmic origins. To find the beginning of our story, we can't start on Earth. We have to go back more than 4.6 billion years, before our solar system even existed. Back then, there was just a vast, cold cloud of gas and dust floating through the galaxy. In this interstellar nursery, hydrogen atoms combined with oxygen born from earlier generations of stars, creating the first molecules of water ice. Research suggests that a good chunk of the water on Earth today, perhaps as much as half, was inherited from this ancient interstellar supply. So, when our solar system started to form, water was already on the ingredient list. But the early Earth was no place for it. Our planet began as a molten inferno, a glowing ball of rock so hot that any water on the surface would have instantly boiled off into space. Geochemical evidence from ancient minerals called zircon shows that liquid water was present relatively early, around 4.3 to 4.4 billion years ago. Still, for a time, the surface was too hostile for the stable, liquid oceans we know today. The stage was set, but the main character had not yet made its grand entrance. The arrival. So how did our planet, born in fire, become the blue marble we know today? The answer, it turns out, is complicated and came from both the sky and from deep within the Earth. For a long time, many scientists pointed to comets, cosmic snowballs, essentially, as the primary delivery service for Earth's water. But as we studied more of them, the story got more complex. Many comets have a different chemical fingerprint than our ocean water, what's known as the deuterium to hydrogen, or DH, ratio. The evidence started pointing more strongly to another culprit, a type of meteorite called a carbonaceous chondrite. These ancient rocks from the asteroid belt have a DH ratio that's a much closer match to our oceans, like finding a shipping label from the outer solar system. But that's not the whole story. Earth had its own water supply locked away inside. As countless volcanoes erupted across the young planet's surface, they didn't just spew lava, they released enormous clouds of gas, including massive quantities of water vapor that had been trapped within the planet's mantle. It was likely a combination of these two events, a cosmic delivery from space and a planetary eruption from within, that gave Earth its water. As the molten planet finally cooled, this atmospheric vapor condensed. And then, it started to rain. Some models imagine a relentless, planetoid downpour that could have lasted for ages, a great flood born from steam and stars that slowly filled the basins, forming the first oceans. The great planetary engine. Once the oceans formed, Earth's great water engine roared to life. You learned its name in school, the water cycle. But the simple diagrams from class don't quite capture the beautiful chaos of this planet-sized transportation system. It has no true beginning or end. It's all powered by two fundamental forces, the sun and gravity. The sun's energy heats the surface of oceans, lakes, and rivers, causing liquid water to become an invisible gas, water vapor. This is evaporation. But it's not just open water. Plants are a huge part of this, pulling water from the soil and releasing vapor from their leaves in a process called transpiration. Together, they create a constant upward flow of moisture into the atmosphere. As that warm, moist air rises, it cools. Colder air can't hold as much vapor, so the molecules clump together around tiny particles of dust, turning back into microscopic liquid droplets. This is condensation, and it's how clouds are born. When enough droplets gather, they become too heavy to hang in the air. Gravity takes over. They fall back to Earth as precipitation, rain, snow, sleet, or hail. And the journey continues. Some water flows into rivers, heading for a quick return to the ocean. Some soaks into the ground, becoming groundwater that might stay hidden in underground aquifers for thousands of years. Some falls as snow on a mountain and becomes part of a glacier, locked away as ice for centuries. Water is always moving, but its path is unpredictable and its timeline is vast. If you're enjoying this story of the ordinary made extraordinary, take a second to hit that subscribe button. Because the most amazing secrets are often hidden in the things we see every day. The journey of a single drop. Let's imagine the journey of a single water molecule in your glass. Of course, we can't actually track one specific molecule through history, but if we could, its story might be a chaotic and unbelievable odyssey like this. Over 4.5 billion years ago, its components were drifting through interstellar space. It arrived on a young Earth as part of an icy, primordial rock. For the next 100 million years, it swirled in the new ocean. One day, the sun's heat lifted it into the atmosphere. It drifted in a cloud for 9 days before falling as rain into what would one day become the Amazon rainforest. A towering fern absorbed it through its roots. For a while, our molecule was part of that plant. Through transpiration, it was released back into the air. Maybe a dinosaur drank it from a stream. It could have been locked deep within an Antarctic glacier for 10,000 years, a silent, frozen witness to the ice ages. Released during a thaw, it flowed into the Southern Ocean, spending the next 3,000 years circulating in the deep, dark currents. Eventually, it was swept into the Gulf Stream, traveled up the coast of Europe, and evaporated near Ireland. It fell as rain into the River Thames. It was drawn into a city's water system, flowed from a tap, and was used to brew tea. After being consumed, it was released back into the environment. It seeped into the ground, traveled through layers of rock and soil for decades, and eventually re-emerged from a natural spring. Every drop in your glass has a story like this, an incredible history that connects you to the deepest oceans, the highest clouds, and the entire span of life on Earth. The water in your body right now was once part of a storm, a river, a plant, an animal. It has been recycled endlessly. The human factor for almost its entire history, the water cycle operated on a planetary scale. But now, a new force is changing the rhythm of this ancient system, us. Life has always shaped its environment, but never has one species altered the water cycle so much, so fast. The burning of fossil fuels warms the planet. A warmer atmosphere holds more moisture, leading to more intense evaporation in some areas and more extreme rainfall in others. We're not just making things hotter, we're turbocharging the entire system, making droughts drier and floods more severe. Our modern world also physically reshapes the journey of water. We pave over porous soil with concrete and asphalt. Rainwater that would have soaked into the ground now rushes into storm drains. Deforestation reduces transpiration, which can lead to less rainfall locally. Through massive irrigation for agriculture, we divert trillions of gallons of water, fundamentally changing where it flows and how it's used. For the first time in billions of years, a single species is actively and globally redirecting this system. We build dams, dig wells, and create reservoirs, effectively building our own engineered water cycle on top of the natural one. These actions have allowed our civilization to flourish, but they also disrupt the delicate balance that has shaped our planet for eons. The story of a glass of water is really the story of Earth. It's a tale of cosmic origins, planetary transformation, and endless recycling. It's a system so vast it can feel abstract, yet so intimate it flows through our own bodies. The global supply of water that carved the Grand Canyon and sustained the dinosaurs is the same water we depend on today. So the next time you take a sip, take a moment to consider its journey. Do you see something ordinary, or do you see a liquid time capsule holding a 4.5 billion-year-old secret? Let me know what you think in the comments. And if you want more science that changes how you see the world, be sure to like this video and subscribe.